So the drive for innovation is tooling around Silicon Valley, the heart of innovation, arguably, of the United States of America, and we're spending some time at Nuvation, which, at least for my money, is probably the coolest, cleverest engineering company that we've come across. We've seen their robotic air hockey game, and now we're with Michael Worry, co-founder, CEO, with another one of your many, many toys. Tell us about E-Rex.
Sure. So E-Rex is an all-electric race car, and we built this originally for the Automotive X Prize. And while we were building it, we discovered that there was not an off-the-shelf battery management system that worked for us. So being an electronics design services company, we took on building our own battery management system, and we've now got that on the side of the car on display and available for license.
So this is the second version of it. How long did it take you to design and implement this?
There's about 2 years of R&D represented here, because when we built the car originally, we encountered a number of engineering challenges, the largest being the communication issues. So you've got a car here that's running surge currents in excess of 1200 amps on a 350 volt DC bus, and then you're trying to run these serial communication lines alongside that to tell all the semiconductors what to do. And in our first generation, you're seeing literally hundreds of volts of surge onto some of those control lines, which doesn't work very well.
But it accelerates incredibly well. You're doing 65 miles an hour and you step on that.
So it's a two-board system, and so each one of these boards, called the pack management boards, can monitor up to 12 cells, and so we have a total of 9 pack management boards in this system, 5 on this side, 4 on the other side. And then it ripples up into what we call the tank controller, because it controls the entire tank, like a gas tank in a car. And it has all the intelligence of the algorithm and so forth, and we're using a microchip processor in order to do that. On the pack management board, we've got a Maxim AFE 17830 chip, which is doing the measurement of the voltages of all the cells, the measurement of the temperatures of all the cells, and then it balances the voltages of all the cells. It's critical in these large format packs that you keep all the individual cells balanced, because you're limited in charging by your highest voltage cell, and you're limited in driving in range by your lowest voltage cell. So by keeping the pack balanced at all times, you both maximize your range and maximize the life of the pack.